So we are going to look at part of 16.2. Due to time, we're not going to do all of it, but molarity is pretty important. Molarity is the most common form of expressing solution concentration. So how concentrated the solution is. And the higher the molarity, so the higher the number of molarity, which we designate as a large M, equals a higher concentration. Okay. So if you had 1 molar hydrochloric acid versus 12 molar hydrochloric acid, okay, this might irritate your hand a little bit. This will burn a hole in your hand, okay? So the formula that we have for molarity, which again is this large M, is moles of solute, okay? So that is what is dissolved over liters of solution, which is um, the total solution that you have, moles over liter. And this is important because if you have milliliters or you have grams, you have to do a conversion. So what is the molarity of a solution of 0.65 moles of solute in 0.5 liters of solution? So molarity is moles per liters of solution. So we have 0.65 moles over 0.5 liters. I don't have to do any conversion there. And my answer is, if I do my calculation, 1.3 molar. Okay, that's how we denote it with that big M. Here we have a solution of potassium chloride contains 34.75 grams of solute in 250 milliliters of solution. So again, I see milliliters here, not liters. What is the molarity of the solution? So molarity equals moles per liters. Well, I don't have moles here, I have grams, and I don't have liters, I have milliliters. So I have to convert both of those numbers. So the first thing I'm going to do is convert my 34.75 grams of KCl to moles. And I do that with the molar mass. 1 mole of KCl is 74.55 grams. And the way that I got that is for KCl, K is 39.1 gram and chlorine is 35.45 grams. Okay, and I just got those off the periodic table and that's 74.55. Okay, that's the molar mass. That's where that comes from. So 34.75 grams of KCl divided by its molar mass, which is 74.55, gives me 0.466 moles of KCl. So for my molarity, I have 0.466 moles over, and I have 250 milliliters divided by 1,000 milliliters equals 0.25 liters. Okay, there are 1,000 milliliters in 1 liter. So you just have to divide by 1,000, all right, or move my decimal 3 places, 250. I can do that. Okay, so my molarity is going to be 1.86 or 1.9 molarity, big M. All right. So if I want to get moles, let's say I'm given the molarity and the volume. If I want to get moles, I use this formula, okay? So moles of solute, it's just rearranged here, equals molarity times liters, okay? So how many moles of solute are in 2.4 liters of a 0.650 molar solution of hydrogen chlorate? So we're going to do it the exact same way. So moles of solute, we're going to use this formula, moles of solute, moles equals molarity, which is 0.650 molar. If you need it, highlight it, times my volume, which is 2.4 liters. Okay, and when I multiply these, I get 1.6 moles of HCl. LO2. Okay. The next one says how many moles of solute are in 150 milliliters. So again, I need to convert. So 150 mils divided by 1,000 equals 0.150 liters. So moles equals my molarity, which is 0.75 times 0.150 liters. And what I get is 0.11 molar. Okay, we're going to do a couple more problems. So here's another. How many grams of NaOH would you need if you wanted to make 1 liter of a 1 molar solution? So because I need grams, I need to find moles and then go to grams for moles using the molar mass. Okay, so remember that moles equals my molarity times my liters. So 1 molar times 1 liter equals 1 mole. Now I need to find my molar mass. Okay, so NaOH, if I look at the periodic table, Na is 23, O is 16, and hydrogen is 1. Okay, just in case you forget how to do that. That's 40 grams per mole. So 1 mole of NaOH, and I have 40 grams per mole. So for this problem, I would need 40 grams of NaOH to make 1 liter of 1 molar solution. Okay, let's try another one. I'm going to erase this real quick, so hopefully you got that down. I'm going to erase it. Okay. This next one says, what if I only wanted to make 500 mils of a 0.5 molar solution? So 500 mils divided by 1,000 equals, this should be a little m by the way, equals 0.5 liters. Okay, so 0.5 molar times 0.5 liters equals 0.25 moles. Now I already know that my molar mass is 40 from the last problem. Don't be confused by the answer to this problem up here was 40 and the molar mass is 40. Okay, so now I have 0.25 moles. So 0.25 moles, and then I just am going to multiply by the molar mass. Okay, so 40 grams over 1 mole of NaOH equals 10 grams of NaOH. See, my moles and moles cancel. All right. So we're going to skip ahead. I'm going to have you do these, the 10 to 13 in the text, but and some from the problem. But we're going to skip ahead to this dissociation review. Okay. So in the dissociation review, it says show the dissociation of the following in water. Okay. Dissociation is something that happens with ionic compounds. Okay. So for the next section, we need to look at